I am Brad Keelor. You are a Director's Cut viewer. Coming up next on our latest Director's Cut special, it's a show all about field work. Hello again, everybody, and welcome to another episode of Director's Cut. My name is Brad Keelor. I'm the director of the Geo-Institute, and that is why we call this show Director's Cut. Every week, except for 1 week at the holidays and during the summer, I sit down with a different GI member who has stories to tell. If you don't know anything about the Geo-Institute, after you watch this amazing show today, head over to geoinstitute.org, and there you will find out all kinds of things about us, including that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and or geologists, and that we are part of the American Society of Civil Engineers. If you like what you see today, and again, it's a clip show. It's like a best of. You should like it, everybody. You should click like, subscribe, and get notifications, and we'll let you know every time we post something to the YouTube channel. Since it is still our 30th anniversary this year, we've decided to do several supercut episodes of Director's Cut, all with a common theme. This week, it's all about field work. Way back in season 3, early on, Sebastian Lobo-Guerrero told this amazing story about site characterization gone wrong. We'll call it that, and it involved a lot of ticks. And that led to the start of the Field Trip series, which you can watch on our YouTube channel. It's got a bunch of episodes, and it's really cool. But we still get lots of amazing field stories in Director's Cut. There are 10 good ones here. Maybe a bonus too at the end with somebody dressed as Ralph Peck. You don't know what you're going to get. Links to all the full episodes that these clips come from are in the show notes below where you're watching this. As always, thanks for watching. Here's Director's Cut, but it's all about field work. Great. In the little intro, we teased this one, that you spent some time at minus 40 Fahrenheit last year as part of your research into the Arctic. Can you talk a little bit about that? Where did you go? What did you do? Why were you there?
Well, first, why I was there, and with the ever increasing air temperature and in the Arctic and around the globe, there are lots of issues caused by it, and one of it is the warming and thawing of the permafrost. The so-called permanent frozen soil, which is not permanent, and when the permafrost degrades due to the warming air temperature, and lots of issues would occur. The infrastructure problems. Roads and houses and pipelines and failures, and people's life got impacted significantly. And permafrost coastal erosion, land loss, and all of those, there are significant, social impact. So we have a few projects and dealing with those issues. And last February last year, before the pandemic, and I went to the Arctic for the second time, but it was in winter time, and it was it wasn't all dark anymore, but it was still very, very cold, and it was negative 40 degrees Fahrenheit with wind chill probably negative 50. It was a very unique experience, Brad.
When Bob Holtz did Director's Cut, he said the coldest temperature he had ever felt was about 33 below zero. So I think you got him beat there. And that one was in Minnesota. What was the most surprising thing to you, your time in the Arctic?
Well, it was my first time seeing the frozen Arctic Ocean. And, I thought it was kind of a smooth in the surface, but really it's a very rough surface. And that's one thing. The other I want to say is I had this kind of unique feeling when I was outside. and it was so cold, and when I breathe, and the cold air coming to my nose and instantly freeze the moisture in my nose. And when I exhaled, and then the warm temperature would thaw, and then the ice would thaw right away. So with each breathe, and the freezing thaw cycle occurs, kind of tickling feeling. I never felt it before. I felt it very funny.
We when I was a kid, we called whatever that temperature is where that starts to happen, we called it the snot line, because it was the point where it starts to freeze inside your nose. And we were playing hockey one time, and it was about 10 below, and that's when we came up with this idea, because we were having the same phenomenon that you experienced.
Yes.
Kind of a unique situation. Not a lot of people get to experience that. Your wheelhouse. And the third question is going to do just that. This is always the researcher practice question. I'm going to talk about a project that you did, and we're going to tie it into running. Oh my gosh, heads are going to explode. Greenpoint in Brooklyn. And now that it's complete, you have run through this. So walk us through your involvement in that project and what it looks like now.
Yeah, so this was one of my first design projects back in the day with Rich Lowe. Got to give him a shout out. So it was for residential property, but in New York City, you have to give 40 to 30 feet of the waterfront's edge for public access to make it equitable for everyone. So eventually one day you'll be able to run around, bike around the whole island of Manhattan, continuous through Queens, Brooklyn, etc. So this project had a little bit of everything, which is why I like it. It had a sheet pile bulkhead, it had a revetment, it had a pile supported platform with outlooks, it had everything in there. So it's fun to design all the little pieces, and then in turn, flip side, go out and be the inspector on site while it's being installed. So that was my first project, being the designer of it and then watching it come to life. And then this past summer, my friends and I, when we were training for the marathon, I was like, let's take a detour. I want to see if it's open. And we ran through the park, and it was just so enjoyable to see people actually using my project, and then explaining to my friends, like, hey, this platform out here is looking at the Empire State Building. That's why it's facing this direction. This one's facing the Williamsburg Bridge. So it was really cool to be part of the entire project process of it and then see it come to life. And I have a few more in the pipeline that I'm excited to run on one day.
Great answer. And now I feel like this next question is, especially after hearing a little preview of your answers, the pièce de résistance of this interview here on Director's Cut this week. What mistake have you made in your career that you still think about regularly?
So, I told you before, I've heard other people get asked this question. They're like, well, yeah, I can't think of a mistake, When you ask
those people are liars, though.
Yeah, you asked me that question, it was like, oh my God, this mistake, that mistake, this mistake, I can categorize them, technical mistakes, mistakes with writing reports, hiring mistakes, business decision mistakes, etc. But the one that kind of stands out to me in the late 90s, we were doing a 74-foot high soil nail wall at the Natchez Bluff in Natchez, Mississippi. And the bluff had failed right up in the street called Clifton Avenue, had gone all the way down the hill. It had dropped like 50 feet. And so these houses were on the National Register of Historic Places. They were fantastic. In particular, there was one called the Learned Mansion. And the failure had gone right up to the steps of this house. And the lady who owned it, Maggie Berkeley, couldn't even get homeowners insurance. So we were nervous that we wanted the wall to be really stiff and hold those houses back. So we decided to put a tieback anchor through the soil nailing, okay, at the very top, and then to stress that against the shotcrete. So I was driving in my car. The construction was underway, and the project manager, Steve Buckner, calls me, and I go, hello? He goes, Maggie Berkeley's house has a basement. And I said, oh, no. So obviously he determined that because he had drilled the tieback anchor into the basement wall. We had no idea. None of the other houses had basements there, this big mansion. So I was like, he goes, well, what do you want to do? I'm like, did you drill through the wall? He goes, no, we stopped. I said, well, just put the tieback on a steeper angle. We were back about 15, 20 feet from the basement wall. And that way you drill under the footing. And so not thinking what we were doing there, we did that all the way along. And so putting that tieback anchor on a steeper angle put a downward component of load when we stressed the anchor on the entire wall. But we didn't think about that. And especially because we were in a soil called loess, which doesn't really bond well to the shotcrete. So when we got down about 25 feet and we dug down for the next lift, all of those anchors pushing down on the wall made the whole wall drop like 5 feet. And that was another call. That one was a late call that had me get in a car and go to the airport. And along with the president of Hayward Baker, unfortunately. But we were able to fortunately jack the wall back up, and within a week we were going again. But that was a big mistake, not considering the fact that I was, with that decision, putting so much more downward force on that wall that it wouldn't be able to support. So
I had one really big question about this story. When you told it earlier, you mentioned that she was a psychic or a clairvoyant.
Yeah. So
why did she? But my question before you go into that, why did she not know this was going to happen and come out and alert you guys?
Yeah, I don't know, but she was famous. I didn't believe in psychics, but she was used by the New Orleans Police Department to find missing persons. The Natchez police would come over and ask her questions. She'd tell them where to look for things. So I never believed that, but she had Steve Buckner and I over for lunch one day. And she gave us some sandwiches, and we were sitting down in her living room, and I was looking around at all this artwork and everything. And she came in, and I thought to myself, boy, she's a really nice looking older lady. And she looked at me and she said, and I was like, oh my God. So I was going like, eat your sandwich. Don't think of anything.
So the third question is always the research question. Today will be no different. What is different is we're going to talk about something we haven't talked about in a while, and that's large-scale field testing. Now, you are going to take an even different tack to this and kind of walk us through the process, because as we were talking before we recorded here today, it's about a lot more than just the experiment or the test itself. So how does this start for you, and what's the journey of large-scale field testing?
Well, having come from Cambridge, which is very flat and quite windy and has rather over-consolidated clays, arriving in Switzerland to find out that I was living in a natural lab was amazing. And a colleague of mine who was a geographer said, Sarah, we need to understand why mountain permafrost is degrading. And we've done some field experiments on what we call rock glaciers. This is creeping rock debris that's full of ice and unfrozen water and air. But we haven't ever had an engineer to look at it. So we put together a project that combined the sort of glaciological, geographical side, the geophysical side, and the geotechnical side. And we went up and we drilled 4 large boreholes and instrumented them with inclinometers and thermistors, so we could work out the temperature, all sorts of other things. And we measured the movement with time, and we tried to understand why a rock glacier was moving as fast as it was, and why it was, whether it was degrading. And then we did it to a number of other rock glaciers as well. We took samples out. We did incredibly careful undisturbed testing on the frozen cores, and we learned an enormous amount about the response of the ice rock debris matrix to loading and unloading and so on. So absolutely fascinating. So that was one of the, and we also worked subsequently on a number of other rock glaciers and measured the most incredible creep at the front of the rock glacier, about 5 meters a year, driven seasonally by what happened with the melting snow that sat on the top of the rock glacier during the winter season. So absolutely fascinating. I realize not so interesting for probably 49 of the American states, but maybe of interest to one. But then from there, we realized that understanding the properties of alpine moraine was of really major interest to many people in Switzerland. So we put together a project that had us sampling these alpine moraines and then raining on them using water from a glacial lake to find out what happened in terms of infiltration of the water, increase in saturation, reduction in suction, and then the potential for a superficial failure. And the fascinating thing was, on a 31-degree slope, we could rain on it like it was a 1 in 1,000-year storm, nothing happened. But on a 42-degree slope, after a few hours, we had a very clear superficial failure, and we were able to back analyze and work out what the parameters were, what the failure mechanism was, and how you would advise those working with structures in this moraine and how they should react as a function of the effect of rainfall. It was really very interesting. And that then spread into other sites in the north of Switzerland, an area which had had 40-something landslides after 40 minutes of rainfall. And we instrumented 2 sites up there, generated our own landslide, and I'll talk about that in the lecture. And then we went down to a scree slope back in the valley to try and understand, again, the mobilization of failure in scree slope. So lots of interesting things where there were phenomena that were unclear, and to try and unpick and understand with a combination of multidisciplinary sort of subject areas, to be able to then make recommendations for example, the communities living below that scree slope, who were worried about debris flows flowing down into the dams that were supposed to restrain them, so that they didn't have suddenly a huge debris flow and ending up in their kitchen and all the rest. So there's impact for the local people as well, and the hazard mapping and so on.
So I think I've got 2 follow-up questions. The first one goes all the way back to the beginning of that answer. And you said that the team told you that you were the first engineer that they had in to look at this problem. Mm. Do you think that was happenstance, or did they know what they wanted you to look at and what part of the problem they wanted you to analyze?
What's fascinating was hearing my colleagues who were geographers talking about failure and stress and everything, and you realize that it's sort of lost in translation. So having somebody who can understand that and who can try and quantify that, and who can try and say, if you have this shear strength parameter, and if you have this slope, and if you have water flowing here, there, and everywhere, you are then at risk of mobilizing 1 million cubic meters of debris that could flow down into the valley below. And they were not able to try and quantify that. They had ideas of what might happen. They were able to see what had happened in other places and to sort of try and back figure the sort of basic phenomena, but they couldn't really understand and quantify what might happen. For example, we know that if we load a specimen this way, or if we load a specimen this way, you'll get different failure states. And that has to be, and if you unload it that way or you unload it that way, likewise. So trying to put that into the thinking around what happens when a large mass of frozen rock debris mobilizes. It's quite helpful to have an engineer involved in the process, but the engineer can't do it on their own because it's incredibly complicated with all of the science around the frozen soil matrix. So it's fascinating, a wonderful learning experience. And I sort of landed on my feet when this colleague came to me and said, would you like to join in? And I said, gosh, yes, that's fascinating.
We always have the research question third in the interview, and sometimes people just say a phrase or give a research topic, and I say, wow, yeah, there's absolutely no way we couldn't talk about anything else. One of my favorites, I think, is scour. For our viewers who watch this a lot, we could have scour all day. Kyle, you're going to talk about blast liquefaction. Come on. How could this not be fun? I think, as a matter of fact, that's really all I have to say. Tell us what you've been working on.
Yeah. Well, about 20 years ago, when we were trying to figure out the behavior of piles in liquefied ground, we were looking for strategies. We could do it in a centrifuge. We could go to field sites where earthquakes had happened in the past and try and see what was going on. But we really wanted something that we could do at full scale in natural ground conditions. So I was thinking that we could maybe get some of those, like the T-Rex oil prospecting trucks to come out and shake and try and liquefy the soil. And I called my friend Roman Ritsu at University of Michigan. See, you've got your Michigan sweatshirt on. And he said, "No, Kyle, you shouldn't do that. You should try explosives." I go, "Oh, really? We could do that?" And he goes, "Yeah, I think we tried a little for my PhD dissertation. I think it will work." So we found a spot where we could do it. I'd worked at the U.S. Navy lab in Port Hueneme and had some Navy connections, and the Navy was closing down Treasure Island that they had occupied for, I don't know, since World War II. And it hadn't gone into the possession of the city of San Francisco yet. And they gave us permission to go test out there. And that everybody knows that liquefaction had been a big problem on Treasure Island because it's hydraulic fill. So we went out and experimented. We set off single charges, and the idea is that stress waves goes through, and it also creates some residual shear stresses that build the pore pressure up to 100%. So we found out with one charge detonating what it would take to cause liquefaction and the distance away that we could do it. Then we set off a whole series of charges, and we found out we could do it. My colleague here at Brigham Young, Les Yaud, had developed pore pressure sensors for monitoring pore pressures during liquefaction. So we used that same technique at Treasure Island. Then we did tests on single piles. We would liquefy the soil with explosives, and then with the actuator from my colleague at UC San Diego, Scott Ashford, we would rapidly load the piles in both directions and put on load deflections clear to 9 inches. And we found out that after it's liquefied, it took maybe 8 times more deflection to get the same resistance prior to liquefaction. So we were getting great results there. We did tests with pile groups. We did tests with different drilled shafts, 2 feet and 3 foot shafts. And we did an add-on where we looked at earthquake drains to see if they would function properly. And we found out we could do all kinds of things like this. South Carolina was having questions about building the Cooper River Bridge in Charleston, and they called Caltrans and said, "What would you do to evaluate this?" And they said, "Well, here in California, we do these full-scale blast liquefaction experiments." And so they invited us out to do those tests out in South Carolina, in Charleston. Dan Brown was involved in writing the specifications, and Dan said, we can not only use those high-speed actuators, why don't we throw in the statnamic load sled, and we'll liquefy the soil, and then we'll fire off the statnamic, and it will create an equal and opposite force on the shaft. So these were 8.5 foot diameter drilled shafts that went something like 140 feet into the ground. And we're expecting liquefaction the top 40 feet. So we would set off the charges. We'd watch the water come to the surface, carrying sand grains for maybe 15 minutes. And then we'd count down the blast and the statnamic, and it would go sliding off. This is like 100-ton sled, and it would go shooting off maybe 50 to 100 feet down the runway. So they used the results we got from that test to design the bridge for lateral spread and liquefaction, and they increased the size of the shaft to 10 feet diameter. I've always wondered what the rationale was, the impact we had on that, but really a fun time for innovation in geotechnical engineering.
So you lived up to the hype. Blast liquefaction is in fact fun. I like that. I mentioned that we were going to get back to Devon Island and Mackenzie Island here a little bit. And for people who have never looked at a map to see where these are, they are those giant islands that you see up in northern Canada that are north of the mainland of Nunavut or of Ontario. Just keep going up and you'll get them on the map. These have always been high on my list of places to visit. That sounds insane, but Pune, there's a very deliberate reason why. Why are these islands so valuable to space science research and operations?
Extreme environment. This is the reason. Then we have Mars Society, which is actually U.S. organization. They even have a kind of Mars analog up there. We do research there. Science, we do science research, and we try just to see how technologies, when I say technology, there are so many scientists up there. They do not develop technologies, but they do science. For example, how we can grow a plant up in extreme environment. We do these things, and I still think it is really, in comparison to South Pole, is accessible. It's very expensive to get there, but still it is accessible for us. And we use it, as I told you, as kind of Mars analog or lunar analog, and we do research and science there.
And can you talk a little bit about the soil and the rock that you find on these islands? Because I believe this is where we get super nerdy, I guess, during this episode, but that's okay. That's what we're here for. I believe there are some parallels between lunar and Martian soil and rock and what you would find on Devon and Mackenzie Islands, correct?
That is true, but from probably geological point of view, I know that, for example, 2 years ago, there was a few US companies traveled up north in Devon Island to do like a tech demonstration for drilling system, for example, for ice detection. But to be honest, I don't think that we've used Devon Island to do geotech. Mm-hmm. I am very, very picky, when we talk about geotech, because I still feel we cannot do geology and say we do geotech research. Mm-hmm. These are two, maybe it's not good to say completely different things, but we see things differently. We both, work on soil and rocks, but the way that we want to get information from those materials, the parameters we need actually in these two fields are completely different. I am not aware of, geotech engineers going up north to do like geotech testing. Maybe I'm wrong. I'm just telling you, I am not aware of, such initiatives. But yeah, they do lots of geology, science, up north because of, if I'm not mistaken, sorry for that, but maybe the craters they can find there. But again, I repeat, from geotech perspective, I am not aware of any the tech demonstration or analysis in such areas. It's not, I don't want to say it is not relevant, but I want to say that this field, Martian geotech, Mars geotech, lunar geotech, they are such new fields.
Yeah.
And emerging fields, in lunar exploration and surface development, that just we didn't get a chance to go there and do like geotech testing.
Maybe someday, and
someday.
Maybe somebody watching this is now going to be inspired to get up there and do some of this. What is the oldest foundation you have ever worked on?
All right. So as you said at the top of the hour, top of the interview, I am from Boston now. Lived here now longer than I've lived anywhere else, and it's a pretty old part of the United States, right? So we're not talking Roman Colosseum old or ancient Mayan civilization old, but still, I've got to work on some pretty cool old stuff. But I'll take it in a slightly different bent or a little bit different twist, and I'll tell you the coolest old thing we've ever found, or I've ever found in an excavation. So we do, dig a lot of big holes in the ground. And in the fill, you pull up all sorts of old bottles and plates and stuff that are pretty cool. But if anybody who's familiar with Boston, there's the Seaport District that you can actually see when you're flying into Logan. And over the last 15 years or so, it's really started to develop. It used to be parking lots and warehouses, and it's really started to become this vibrant part of the community. And so we were working fairly recently on this 7-story office building. It was going to be a 17-story office building, and digging a big hole in the ground for that, a slurry wall around the outside, and we're digging down and we're digging through the fill. And Boston's got a lot of history where we filled in a lot of land. We needed more land, so we filled it in, a whole bunch of fill. And we're getting to the bottom of the fill, and we're starting to get some wood. The excavator, the earthwork contractor's pulling out some of these wood, starts to excavate a little bit more. Turns out we found a 50-foot long, 19th century old lime schooner that had basically, it was in that time, late or 1900s, 1870s or so, from Rockport, Maine, they would bring down all these boats in these lime barrels. And we know it's lime because we dug up an old lime barrel that said, Rockport Lime Company. And lime can be pretty reactive. So it's probably something caught fire while they were waiting in the harbor. Ship burned. The back of it was all burnt. You could still see it charred, sunk to the bottom. And, rather than trying to salvage it or pull it out, when they started to fill in all that area of Boston, they ended up just filling right on top of the boat. And so, it's pretty cool. So we actually called, or the contractor at the time called the Boston Archaeological Society, and they came down and actually managed to take large sections of the boat out, and they found some plates and forks on the boat that they could date very specifically, that they hadn't been made until 1869. And we know that the Boston Harbor in that area was filled in 1886. So, they could date, even though there was no record of this ship fire, they could date almost exactly when it happened. And it was just pretty cool to be standing at the top of this big hole, looking down at the excavation and seeing this giant ship. I mean, you can Google, Google ship found in Boston excavation, and you'll see these pictures of it. It's really neat. It's kind of
where did you follow what happened to the pieces of the ship and the artifacts that were found? Do you know where they are today?
Yeah, you can actually the Boston Archaeological Society has a GoFundMe page and they're trying to raise some money so that they can continue to preserve it. And so they have big chunks of it, and they actually have a website that you can go to, and it talks all about it. So it's pretty interesting.
Well, that is very cool. So now we're going to dive into some of this research.
Mm-hmm.
And yes, you do have some research topics that are a little bit out there. And the one that's really out there that I want you to talk about first is kangaroo rats.
Mm-hmm.
How did you start looking at kangaroo rats, and why?
Yeah, so I get this question a lot. It all started with a vacation, actually. My sister and I went to Peru, Bolivia, Chile. We spent 2 weeks there. And during that vacation, we went to see a few deserts, Ica, Peru, and then most impressive one was the Atacama Desert. And we spent 3 nights, 4 days there, just driving around and seeing all these different formations in the desert, experiencing those extreme environmental conditions, the fluctuations. I got sick, so sick, part of that trip. Anyway, but I came back super impressed by those desert environments, and I went to a happy hour event, and I met with my friend Clint Collins, who is also a co-PI of my kangaroo rat project now. And he said he studies desert animals, how they jump on the desert biocross, the biomechanics, especially kangaroo rats. And that was all I needed. I was already super impressed by the deserts, and then this animal, he showed me the pictures. It was just the cutest animal. And then I started to read about these animals. We talked more with Glenn, and then for the next month, I just basically focused on biology papers. I kept reading and getting more excited and interested. And then finally, we came with this big question that how can these animals construct stable burrows in loose sand? And in those extreme environments, in desert conditions, how can these burrows stay stable for long times? So we will be hopefully finding some answers to that in the next 3 years.
So the follow-up I have to ask here, before we started recording, I told you the first time I heard about biomimicry and what got me interested in it. Do you remember the first time you heard that term, and was it immediately interesting to you, or did it take a while?
Yes, it was. So I don't really remember the first time I heard the word, but the first time I actually learned about it was the workshop that Alejandro and Jason at UC Davis, they organized a workshop on bio-inspired geotechnics. That was the first one. And that was the best workshop I've ever been to, probably, because half of us are geotechs, half of us are biologists, and first time I got to see how biologists think and seeing all these overlap between geotechnical engineering and biology. It was very eye-opening and very exciting. That was the first moment I actually got excited about this.
So I really don't want this to go to their heads, but I feel like it's like every 3 episodes we do a shout out to somebody at Davis.
I know.
So we shout out Alejandro Martinez and Jason DeYoung at Davis this time. Next time, who's it going to be? Could be Katarina, could be Ross. You know, we just don't know. No different. We're going to talk about a project that you have been working on, well, that you're working on currently nearby. I mean, it's called Revere High School. How Boston is that? And it's a ground improvement project. Can you walk us through it? First, just walk us through it, and then tell us what's been challenging about it or what's so special to you about that project.
Sure. Yeah, so the Revere High School project's been my baby for the past year or so. Fascinating project, super challenging geology. As you know, Boston is well recognized because of the compressible Boston blue clay deposits, right? So this is like the perfect setting. You get your urban fill, organic layers of very, fibrous peat, highly moisture content. Then you get desiccated BBC Boston blue clay, which is across, it's decent in some areas of the state. And then very soft, very deep deposits of compressible clay. So when we look at this project about a year ago, it was spec'd to go shallow. Okay, so shallow, like you can support your footings. What we call shallow in Boston is supported on the Boston blue clay crust, right? Because it's desiccated, as indicated, over consolidated. But this one had very tricky design concepts. They were lowering the floor of finished floor elevation below existing grade, very close to the groundwater table elevation, very close to the soft organic deposits. And then on top of that, one of the biggest school I ever seen in my career, 180,000 square foot building, right? Footprint, up to 5 floors in one of the wings. In addition, another 200,000 square foot for fields, pads, parkings, access driveway. Anyways, crazy, with some areas up to 14 feet of grade raised fill. So when we hear that in the ground improvement world, it's just like, come on, bring it on. So we started our design, preliminary design and good stuff, and found out that it could not be supported shallow. The loads were too heavy. The stresses were going to reach that soft compressible deposit, translating into unmanageable settlement criteria, right? So we propose a deep ground improvement solution, okay? And what it means, we needed to bypass that soft clay layer, bringing all the load into the glacial till. So we are, as you indicated, we are installing there since January. We have installed about 7,000 control modules columns, and that's about 50% of our overall production, expected production. We got elements from 16 feet for the slab support that could be shallow on that cross, up to about 110 feet for the footings and mats down into the glacial till. So it's been very challenging, pretty awesome, very rewarding. We have completed like 5 different load tests, and they all have been very successful. So very happy to be part of it. And in addition to that, I get to sit on a CPT rig for a week because we found some stuff that, were a little tricky. So we wanted to evaluate that. So CPT rig for a week. And I got to oversee SPTs. I was like, oh man, back in time, 15 years later, I'm logging boring logs again, which was pretty cool. So it's still going probably until the summer, and very happy about that project. So that's probably the highlight of my career lately.
So is it part of a much larger renovation, or is it an isolated project that you guys are working on there?
Brand new school.
Wow.
This site actually is fascinating, right? It used to have a track, and I'm confused of if it was the horse. I think it was the horse racing track, and all the different structures that he had about it. They had some concession buildings and whatnot, right, related to that. But that's what it used to be, and it was abandoned for many, many years. And so you look in the map in Google Earth, and you still see the track in there, and that's where the main school is going, right? So it's completely isolated. My son had a soccer game at the Riviera High School 2 weeks ago, at the existing Riviera High School, and I went over. It's still massive. It's still massive, but all old and rough shape. So it's interesting to see. The new schools are just enormous. That's here in New England. Yeah.
This is an amazing story.
It is funny now. It wasn't funny at that time, but I'm ready to say it. I don't know if I was ready at that time.
What is the funniest mistake you've ever made?
Yes, so it is funny, and I have no problem recognizing it. So it was 2008. We were doing a project on the other side of the state. I'd rather not say the exact location. So we were going there, and we spent 2 days, and we were supposed to go with one of my colleagues, one of our senior geologists. Well, now at that time he was not, but and we were gonna go and do some geologic mapping, some rock cuts. We were doing the project itself. Kind of had some cuts on rock. It has a roadway part. It has a bridge replacement, and this is extremely important for the story. It had a little lake that we were doing a geosynthetic reinforced soil slope next to it. So we went there. We drove the day before. We stayed in a hotel very close to the site. Next day we wake up early, went to what we thought it was the site, start walking around, start looking at the cuts, start doing geologic mapping. This is the best. Like, we actually measure all the dips, stride, discontinuities, full detail on everything. Then we went, look at the ridge. Things start looking a little weird because the ridge looks like almost brand new. And I think that's when I say that's weird. But hey, we're in the States, and it's one of the richest countries in the world. So as far as I'm concerned, they may be replacing a ridge that is brand new just because they can. So and my colleague is from Jordan, right? Al Hardawish. So we were like, yeah, that's weird, but Americans, that's what they are. And then we continue. We went where the geosynthetic reinforced soil was supposed to be. I think one of the primary concerns that the senior engineers in our office at that time had was settlement and different presence of clays because of the lake. So we go into the woods, we keep doing the area, and then I start asking my friend, where the hell is the lake? Because we don't see the lake that is supposed to be. And then it hit us, right? And it's like, dude, are we in the right place? So we realized, and I'm obviously this is before, like these days when we visit a project site, you just put the coordinates on your phone and you make sure. This is before that. So we were just going with like plan and stuff. So we came out of the woods, we realized it's the wrong place, right? And I mean, that sucks because we probably wasted like a good amount of time the whole morning, and we were planning to drive to Pittsburgh in the back, but that probably is not the best part of the story. So recognizing the fact that we suck on that, we went to the right place, did the recon, get everything done. It was a very long day, and then we start driving back to Pittsburgh. And when we are in the car, my coworker, my friend Ali, is driving, and I start seeing one tick going out of like my sock and start climbing into my pants. It's the first tick that I saw coming to the States. I never saw ticks before. We have ticks in Colombia, but they are not as nearly as dangerous as they are here. So I show my coworker, I'm like, hey, look, I got a tick. And he's like panic mode, immediately pull on the side of the road. And then we dispose of the tick or whatever. Then I keep looking and I saw one more. So at that point, I just kind of drop it. And then we continue driving. As we continue driving, I found a third one. And we were lucky enough that we were very close in the turnpike. Anyone that is familiar with the turnpike, with the Blue Mountain Plaza. So I said, you know what, just enter there, man. Let me just get off, go to the bathroom and check the rest of my pants. So I end up going there. I count, just at that bathroom, I counted a total of 12 ticks in my pants, different locations of my pants. I freaked out, right? I mean, this is like a terror movie, all the ticks climbing. So I'm like, shit, this is not going very well. So I take them off, and then I was like, I'm not going to be able to take every stick out of it. So might as well just dispose the entire pants. So I opened the stall door, right, on my boxers. I mean, I guess it's important to wear nice underwear every day. You never know what happened. So I go on my boxers, right, and my boxer shorts, and I literally just say there is no point. So I trash my pants. And then I was like, how the hell? I mean, I have my wallet in one hand, my flip phone in another, my keys, and just walking out of the plaza. And I literally just walked the entire Blue Mountain Plaza in my boxers with these things on my hand, come out to the car. Ali's looking at me and he's like, what happened on that bathroom? And it's like, why are you? Fortunately enough, since it was a 2-day trip, I did have another set of pants that I could put right there on the parking lot. Nothing classier than putting pants on the parking lot of a turnpike plaza. And then we left. So, yeah, I mean, it was funny. I mean, well, it was a little funny at that time. For Al, it was very funny. For me, I don't think it was very funny. But it also shows a couple of things. The first one is, what I was telling you the other day, which is tragedy plus time equal comedy. And it's great to kind of think about these stories. If you ask me technical aspects of that project, I probably have forgotten most of them because it was, 14 years ago or more. But I always have the stories. And then the friendships that I have with Al, for example, they stay forever, right? And then we talk about these stories and many other things. It also, for me, is a lesson that is important to learn because, obviously this was a long time ago and we were kind of starting our careers or, I guess in the early part of our career. And is that sometimes the attention to detail, it gets you lost and is your worst enemy. It's important to have attention to detail, but it's extremely important to never lose the big picture. And the big picture is that, we should have double check, triple check that we were at the right side before we start taking readings of discontinuity of joints on bedrock, right? You know what I'm saying? So it's a lesson. It's a funny story, but it's also a lesson, I would say, for younger engineers to never lose your north, never lose the big picture, because the big picture is more important.
The other thing we talked about before we started recording is that no security personnel, no employees from the rest stop, from the Turnpike Authority, came and talked to you when you weren't wearing pants outside.
I know.
And that leads me to believe
it's insane.
that their day must be way weirder than that.
For me, that was insane that I was just walking, boots, boxers, phone on my hand, and wallet, and nobody even approached me, right? Everyone is like, yeah, it's a normal thing. That happens a lot on Blue Mountain. So, yeah, I think I got a better understanding for that sticker they put on the plazas that say, like, shirt and shoes required beyond this point. It's like, yeah, I guess some people do what I did. So, yeah, I'm sure many, like, that tape, that security camera tape has to be somewhere. And, I will pay top dollars to seeing that. Because as I said, right now I'm very relaxed about telling it. I don't think at that point I was on the, on the same boat.
I can't imagine you would be. That is an amazing story, though.
And those are some of the best answers to some of the questions I've asked about fieldwork over the past 7 seasons. As a reminder, you can check out the full interviews of the shows those clips came from by just following the links that are down in the show notes below the window that you're watching this in now. If you haven't watched full episodes of Director's Cut already, well, I question what you've been doing for the past 7 years. There are 274 episodes, plus shorts, plus bonus episodes. There's so much. Get to know your fellow members, get to know a geo legend, a mentor, a student. There's so many reasons to watch Director's Cut. And you can get audio versions wherever you get your podcasts. Audio, video, we've got all the proverbial bases covered. If you liked what you saw today, and you're here at the end, so you probably did, again, click like, subscribe, and get notifications, and we'll let you know, I promise you, every time we post something to the YouTube channel. Keep watching these special supercuts, and remember, we're going to be back in September with brand new episodes of Director's Cut. Next, we got to go to the one we teased at the beginning. We have to have a couple of spooky questions in here, and so this was a pretty easy one to throw in. What's the spookiest project you've ever worked on?
Well, yeah, it really was a little spooky. We rescued a zombie barge, and I just Googled it, so you can Google zombie barge, and it was on Navy Pier, and they were doing a special Halloween show, where you said
it was even at Halloween that this happened.
That was the point of it. They brought in a barge, and they had zombies all over it, and it was like a haunted house, like a floated haunted house.
But wait a minute, I thought zombie barges were ones that were just rogue and were drifting. This was an actual barge that had zombies on it.
Yes, covered with zombies. And the zombies were floating around like corpses, and they were underground. Like, we had divers involved. The zombies, they weren't the undead, they were dead zombies. But it was a Halloween show that they were putting on. They sold tickets to it, and this storm whips up at the end of October, as it tends to happen in Chicago, and the waves and the wind just smashed the heck out of it against the pier, and it sank, and it destroyed the zombie barge before Halloween. They had to refund all the money and pay us to float the thing back up and rescue the zombies.
Wow.
That's weird.
I like that. That is perfect. Director's Cut, I like to say, it always works out. I had no idea when I put that question in here. I love that. So